Hello and welcome to another activereach technical tutorial video. Just going to have a very quick look at Nmap for Windows. Nmap is a port scanning utility which was primarily created for Linux and Unix before it made its way onto other platforms such as Windows. In its most basic form, it just scans a host for open ports. So let's just have a look at a basic scan on a router on my network here. If we do Nmap and then the IP address that we're scanning, like this. It just takes a while as it runs its port scan, and then after a while, depending on the speed of the network, among other things, it will come back with some results. And we can see that this IP address that I've scanned here is showing as open on port 23. Now the scan took a little while, and it might be easier to just scan the host and specify top ports, and then say the top 20 ports. And this will just scan the top most popular ports and give you the list for all of those, instead of scanning all of the whole thousands of ports, which most of them might be closed. And there we can see Telnet is open, and it's showing us the rest here is closed. You can also do an OS detection on it, so we can do a capital O, and that will detect the operating system that's running on it. You can see it just takes a while. If you're wondering what's happening to your results, just press the down arrow or up arrow, and it will just give you an update on how far it's gone. So you can see when I pressed the arrow there, it was just telling me it was 89% done. And once that scan's done with the OS detection, you can see it's got the MAC address, which tells us it's a Cisco device because the MAC address contains the vendor. And it's also told us the OS here. Well, when you're sending TCP packets to a device on a network, it responds in not a unique way, but in a certain way, and it can give clues as to what sort of operating system is running. That's what you call TCP fingerprinting. The way a device responds can give away characteristics about itself, and machines on the internet and devices on the network, when they respond to TCP probes or TCP packets, the way they respond tells the device that sent the data a little bit about itself. So you can make educated guesses about what operating system a device is running. So this is made, it's able to see that this is a Cisco router running Cisco IOS. Of course, that doesn't always work. If something's behind a firewall, or certain operating systems might not give up that information so easily, but it can be a very useful network analysis tool. You can do a faster scan, which is useful, rather than it taking quite as long. Add the flag -F and it'll just run things a little bit faster. You can see that one did it in 4 seconds, whereas our first scan with the exact same command did it in 9.8 seconds. So it took twice as quick to do it. And all that really does is just scans the top 100 ports anyway. So that would be the same really as doing a top ports 100, and that will probably take the same amount of time, about 4 seconds. Okay, it's taken 3 seconds that time. If we want to scan a host on the internet, it'll do the same thing. Let's have a look at nmap.org. We just press the down arrow, just tell us how far along we're going. 1% into our scan, now we're 40% into our scan, 89% into our scan, and we can see these open and closed ports on nmap.org. And maybe if we add OS detection to that, let's see if we can tell what operating system nmap.org is running. So it says OS detection report here, no exact OS matches, but it takes a guess based on what it's seen. So it says here it's probably running Linux, or maybe HP embedded system, or some kind of embedded OS there. Could be useful depending on what we want to do next with that information. We can scan just an individual port. If we want to know if something's open on the telnet, we can just say -p with a lowercase p 23, and that'll just scan that port. If you want to port 80, that'll just tell us that yeah, that's closed. Sometimes if you're scanning a host which is blocking ping, let's say have a look at netflix.com. You can see that it doesn't respond to ping, and if you do an Nmap scan on it, it might say that it can't see anything because it doesn't respond to ping. So you can remove the ping option from Nmap by doing Nmap netflix.com -uppercase P and a 0, and we'll just add fast to that. And even though it's not responding to ping, it was because we know Netflix is up because we were all browsing it earlier on. So we can see that indeed it is showing as open on port 80 and port 443, even though it's not responding to ping. So ping might not be the best way of telling if a host is up. It's just because a host doesn't respond to ping doesn't mean it's down. It just means it's not responding to ICMP. It might be blocking the ICMP probe. So sometimes a port scan will actually connect directly to the port, the relevant port, and give you the information another way. You can also do a UDP scan. So if we do a UDP scan on the local host, to do that it's -su, and this might take a bit longer because UDP isn't as fast as TCP in the way that it in its response. To know that a UDP port's open, you have to be able to tell that the data's made its way to the target without the target responding, which can sometimes be difficult. So it takes a bit longer. 50% through, 62% through. So it's just probing the system, sending the UDP packets, trying to figure out which is open. Almost done. And there we go, it's just given us the UDP ports. Where you see here where it says open filtered, UDP, because the UDP can't really, it's not a responsive protocol. It doesn't respond in the same way as TCP. TCP has a three-way handshake to establish a connection, whereas UDP is just one way. So it always comes back as open filtered because it's not really, Nmap can't really tell if it's actually going to respond on that port or if there's a firewall that's going to block it somewhere. Ports generally come back either as open, closed, or filtered, and UDP ports will often come back as open, filtered. The difference between open and filtered just means that the port's responded, but something may be blocking it, something might be in the way. So when you connect to a port and it says it's closed, it's a very surefire, this port is closed, you cannot get onto it. But if it's filtered, it means that the port might have been open and might have accepted traffic to it, but it hasn't given enough of a response to tell you that it's closed. So a filtered port can be very frustrating for a network administrator or a hacker or somebody trying to figure out a bit more about a host, because it really doesn't tell you an awful lot. Open and closed gives you a definitive answer, whereas filtered can be a little bit more frustrating. So it's a very useful utility. It can give you all sorts of useful information. There's lots of parameters that you can add to your scan, which you can have a look at by just typing Nmap, and it will just give you all the various flags you can use. And yeah, you'll use the ones which you find the most useful to you, as I've shown you. -f can be useful, the -top ports can be useful. I hope that's been helpful to you. Thank you very much for watching.